Okay, this is going through the rest of the mixture notes for those of you that need some additional help or may just want to see a few more of the examples. This came off of the other screen, which was over here. We had done the first one in class, which I feel like we were probably pretty good with. The answer here was 43.3% sugar, the final mixture. If you have questions on that, please come see me. Then we moved to this problem. Okay, and I'm going to talk kind of quickly through these. So in this one, the first thing, I have A, I have B, and I'm going to be dumping them into a new big bowl, you can visualize, for my total, my new mixture. So the first thing is, do you know how much of cereal A you're using? And if you read up here, you don't, so we're going to call that X. Do you know how much cereal B you're using? No, I'll call that Y. Do I know how much is in my final mixture? Yes. 1,000 grams, which is the same as 1 kilogram, because some of you may be confused where 1,000 came from. It said 1 kilogram, which is 1,000 grams. Now, in this big bucket of cereal A, I have X grams of cereal, but not every single gram is sugar. Only 38% is sugar. So to figure out how many grams of sugar I have, I would find 38% of the total amount of grams I have. That'll give me the grams of sugar. Okay, so under here, this is giving me grams of sugar in A. In B, I have Y grams of cereal, but not all of them are sugar. So to figure out how many grams of sugar I have, I need to find 46% of the total amount of sugar that's in there. So again, this is giving me grams of sugar of B. So my grams of sugar of A and grams of sugar in B should add up to be how many grams of sugar are in the total. Well, not all 1,000 grams are sugar. 40% of the total is sugar. So there's 1,000 grams of cereal, but 40% of those grams are sugar. So when you do that, you'll get 400 grams of sugar in the mix. Okay? It's not 0.4 grams of sugar. This is for 40% of the total to give us 400 grams of sugar in the mix. I did not go through the steps of solving this. I can help you with that, but you should be pretty good with solving systems by now. Your final answers should be here, 250 and 750 grams.
Mr. Hoffman, please call the office.
All right, in the next one, we have Mountain Dew is 55% caffeine, Mr. Pibb is 41% caffeine. How many milliliters of caffeine would be in a mixture that contains 30 milliliters of Mountain Dew and 50 of Mr. Pibb? So you see I made a very similar visual to help me organize my information. There were 30 milliliters of Mountain Dew, 50 milliliters of Mr. Pibb, and that makes, logically, 30 plus 50 is 80 in the total. Then, I know not all of these are caffeine. 55% of all of those milliliters are caffeine. So I did 55% of 30. That gave me 16.5. 50 milliliters, not all are caffeine, 41% are. So 41% of 50 gives me 20.5. So that means I have 37 milliliters in the mixture of caffeine. The mixture has 37 milliliters of caffeine. In number 2, it says what percent of the mixture in number 1 is caffeine. Well, the part that's caffeine is 37 over the total amount of milliliters, which is 80. That gives me 46.25%. Okay, these discuss a few questions that we did in class. Can you make a 60% caffeine mixture from these two sodas? No. The highest you could do would be all Mountain Dew, and that would only be 55%. If you're only using Mountain Dew and Mr. Pibb, you cannot get above 55%. And the same reasoning is here for getting a 30% caffeine mixture. So again, you can push pause and write these down. If you have a question you're not quite sure what I mean, you can write that down too and come see me and we'll talk about that. All right, the next one we have Mr. Mach's spinach dip is 25% spinach, while Mrs. Ildrenfritz's spinach dip is 40% spinach. Mr. Kelly wants a dip that is 30% spinach and he needs 70 cups. How much of each dip should he use? So I started with the same visual. Mr. Mott's, I don't know how much to use of his. That's what I'm trying to figure out. Mrs. Ildrenfritz, I don't know how much to use of hers. I put the wrong things here, sorry. But I do know there's 70 in the total. Now, in Mr. Motz's, it's not just a big bucket of spinach. There's other stuff in there, too. So I know 25% is spinach. So to find how much spinach, I would find 25% of the total, which is X. So this is giving me cups of spinach here. Again, Mrs. Ilgenfritz has Y, but they're not all spinach. There's some nice cream cheese, some other stuff in there. Only 40% is spinach, so I'm going to find 40% of the total, and that'll give me the cups of spinach here. And Mr. Kelly's is not all spinach. It has 70 cups, but he wanted 30% to be spinach. So to figure out my cups of spinach here, I would find 30% of the total. See how I'm continually finding the percent of the total and remembering what that means. And again, I didn't solve the systems for you. We should be pretty good with that by now. But these are the answers that you should get, and these should be cups. All right, for the next one, this is looking at it a little differently with averaging on a test, but it's using the same idea. So we have early algebra averaged and 80% on a test, afternoon algebra averaged 90% on the same test. If 50 early students took the test and 90 afternoon took the test, what would you expect the average to be? So again, if you think about it, here's 50 students, 80% of 50, 90% of 90, that gives me my part over a total of 140 students. The 140 here is coming from 50 plus 90. That's where the 140 came from, and then dividing it to get the percent. In number 2, how many of each type of student would be needed to get a group of 100 who would average at an 82%? So I made a very similar way to organize my information. I have early algebra, I have afternoon algebra. I don't know how many earlies, I don't know how many afternoons, but I do know there's 100 total students. Over here, 80% will score, so I did 80% of the total. Okay, so 80% of the total, 90% of the total, and I want that to be 82%. Again, the 82 is coming from here. Of the total is 100. And again, when you solve that, these are the answers you should get. So I'm hoping you're starting to see we're having an equation relating the parts to the whole, and then we're looking at the individual pieces of it. Not the whole thing, the part that, let's say, passed, the 90% times Y would give me the number of people who have passed. The 82% of 100 gives me that idea of the number that have passed. So it's always percent of, percent of, percent.